all for being over here. What I would like to do is take a quick 1 minute to appreciate and recognize the work of our advisory team, which is on the board. Could all the advisory team be here, please? So I can just introduce Kanaya Vasani, Dr. Vishal Sharma, Rajesh, Rajiv, I'm sorry, Rajesh. Yeah. I've changed Rajiv's name. Mukesh and Atul, Rakesh, and Guru. Everyone knows Guru in SDI. So we really appreciate all these, they are experts. As you know, Kanaya is a VP of Corp Dev at Juniper. Dr. Vishal Sharma, he's got his own telecom and networking consulting firm he's been running after his PhD for a number of years. Rajiv used to be former VP of engineering at Juniper. Started there before there were 10 people. Mukesh is a serial entrepreneur, co-founder and CTO of Transera. Atul is again an entrepreneur as well as right now VP at VMC Software. Rakesh, and he's also at VMC. And then Dr. Guru Parulkar, he's an entrepreneur as well. Now, even though he has a professor title, he was founder of Growth Networks, which was bought by Cisco, and he's been part of the whole SDN phenomena. So I really appreciate you all the time with that. What I would like to do is, and also some of our volunteers and some other advisors who are not here, their names, and without their help, they've been putting a lot of time and effort since late last year to make sure we provide you the experts in this area called SDI. By the way, we haven't trademarked that name. We came up with this name called SDI. What it meant is it will include networking and storage instead of just saying SDN. I know Guru didn't like it at that time, but we still went with it. Just kidding. So with that, I would like to thank you all again. And I'd like to introduce Rajiv Patel, who is going to introduce our keynote speaker.
Good morning and a warm welcome to the Software-Defined Infrastructure track at TiEcon 2013. I'm Rajiv Patel, and it's a great honor to introduce our morning keynote speaker, Dave Larson of HP. David Larson is Vice President and CTO for HP Networking and leads the Advanced Technology Group within HP Networking. Dave is a networking and security professional and has also been an entrepreneur with over 20 years of experience in this industry. He brings to HP a proven track record of successfully creating technology and market differentiation in both small-scale startup ventures as well as established public technology companies. Please join me in welcoming Dave as he talks about software-defined networks.
It's an honor to be here today to speak with you all about software-defined networking. It is a particular honor for me to represent one of the truly iconic and entrepreneurial brands of the technology industry, Hewlett-Packard. As many of you know, Hewlett-Packard was established nearly 75 years ago by Bill Hewlett and David Packard in a garage just up the street in Palo Alto. And their spirit of entrepreneurship and their thirst for innovation is still alive and well today at HP. And I'd like to share how software-defined networking is an example of that fact in our company. First, I'd like to start with a quote from David Packard that I think is illustrative of where we are in the market today. He once said, "To remain static is to lose ground." In the networking industry, I would argue that we have remained too static. That's not to say that there hasn't been innovation, there has. In the 20 years that I've been in this industry, we've seen interface speeds go from 10 megabits to 100 gigabits. And we see terabit speeds coming in the near future. We've seen huge feature capability on the products that we ship to the market. But in one really important area, the network has really not changed in the last 30 years. And that's the way networks are deployed, configured, managed. And that is in a very static way, using command line interfaces and scripting technology. So 20 years ago, when I was an IT administrator and I was building networks, I built them the same way we build them today. Unfortunately, that does not scale with the needs of our world today and the advent of cloud. And so I'd like to talk to you first a bit about where we've been and what the trends are in the market and how they impact and are driving the need for the development of software-defined networking. So the first is that legacy systems as they exist today are very, very fragile, and they are very complex. And as such, they are very difficult to map to emerging anything as a service offerings. With the advent of cloud, people are realizing that there is a real business advantage to being able to deploy elastic resources, network as a service, software as a service, infrastructure as a service, and yet IT administrators have a daunting challenge of how they might map that to their fragile legacy environment. Additionally, there is an explosion in device connectivity to the networks with the advent of real mobility. It is no longer the case that the presumption of connectivity is a corporate-owned PC. In fact, more and more enterprises are working to support entirely user-owned equipment in the form of tablets, smartphones, and laptops attaching to their network. This is a paradigm change that is stressing the way the Ethernet edge is architected, the way the Ethernet edge is secured, and the way the Ethernet edge is managed and deployed. Software-defined networking offers real opportunity to enable acceleration in this area and real responsible use of a bring-your-own-device model. As the BYOD environment indicates, there is a real security impact as well to how networks are evolving. The threat environment, the threat landscape, the morphology of the attack vectors is such that human manual intervention simply cannot compete with it. Additionally, the Ethernet access layer itself has traditionally been viewed as natively secure. When you believe that the only things connecting to that portion of your network are corporate-owned devices that have the appropriate security software and patches installed on them, you might be able to get away with that notion. In today's wireless BYOD world, this is now a new threat vector for malware, botnets, spyware to enter the enterprise. And I will speak in a few minutes about an actual application that we are developing to address that issue. So with those, we also see three big infrastructure trends that are emerging in the marketplace. I'm sure many of you are familiar with these. The first is converged infrastructure, the convergence of servers, storage, and networking into common platforms with a common management model that scale to cloud-scale environments. In addition, there's a notion of software-defined data center, which incorporates software-defined infrastructure, software-defined networks, servers, and storage, as well as the advent of cloud that makes use of these models in order to scale to the needs of the environment. In all three of these cases, the network itself is the substrate on which those other paradigms will succeed or fail, and software-defined networking will enable new value in these areas. So at HP, we have a vision for the future of networking. We call it virtual application networks. That is the architecture of which software-defined networking is a critical tool and component. Virtual application networks will allow enterprises to focus less on thinking about managing the infrastructure and the people and manual processes associated with it, and allow the organizations to focus more on quality of business experience. It's about time that organizations were able to extract the business value of their investment in the network and not view it as a blocking element to getting things done. So when we view software-defined networking, we describe it in a stack of 3 layers. At the bottom layer, there is infrastructure, and at the infrastructure, we expect to use open and standards-based interfaces to the switching and routing elements, whether they're physical or virtual, to abstract the data plane and control plane. In this case, we are an adherent to the open flow protocol standard on the southbound side. At the control layer, we separate the control and data plane, and we abstract the control of many devices in the underlying network such that you no longer view your network as 124-port switches. You can now view it as a single logical fabric of a single device that contains 2,400 ports. And we expose the network functionality of the underlying devices through open and RESTful northbound APIs. These APIs allow the development of applications through the service abstraction that will totally disrupt the way networks are deployed, configured, and managed today. At HP, our SDN solution is comprehensive. We have offerings across all 3 layers of the stack. At the bottom layer, you can see that we lead the industry in having delivered 40 switching platforms that are all OpenFlow enabled to the market to date. This represents more than 20 million shipped OpenFlow enableable ports. So our customer base is well armed to begin working with this technology. At the control layer, we have delivered our own Virtual Application Networks SDN controller that is delivered either as a hardened appliance or as software that you can run on your own hardware or as a virtual machine. And it abstracts the control plane from that underlying infrastructure and presents northbound APIs that enable the development of applications. The first application that we announced is our virtual cloud network application that we delivered in conjunction with HP Labs and HP Cloud Services as in the foundation of the management element for our self-service virtual private networking portal. In addition, we have delivered something that we call our Sentinel security application in conjunction with an effort at HBO that delivers a secure Ethernet access layer on top of our OpenFlow switching equipment. The third one is a load balancing application that we developed in conjunction with CERN, which is the nuclear research organization in Geneva, Switzerland that recently discovered the God particle. As you can imagine, with their kind of science activity, they generate petabytes of data and they move it around the globe to their global research organization, and they have real requirements for load balancing capability in order to service their needs. So we worked in conjunction with researchers in their environment to develop an application for their need for load balancing. But when we talk about software-defined networking, we do not believe, nor do we expect customers to rip and replace everything that they have already deployed. This is not a greenfield opportunity in many cases. We view this as a brownfield opportunity where we need to marry the legacy infrastructures to the emerging SDN capabilities that we are delivering on our products today. To that end, we also have mechanisms to be able to coordinate non-OpenFlow devices for these solutions. The way we do this is through the management layer. Our Intelligent Management Center is a heterogeneous management platform that is able to manage thousands of non-HP infrastructure devices and to marry their capabilities with the software-defined networking capabilities that we are delivering to the market. In addition, we expose APIs both from the controller and the management platform to integrate third-party applications like F5 iApps, like Microsoft Link. And I'll talk about Microsoft Link in specific in a moment. So now I'd like to go through a couple of applications that we are delivering today in the form of beta products on our beta controller. And so these are lighthouse customers that are testing and utilizing this capability in the market. The first one I mentioned earlier, which is the Sentinel security application that we developed in conjunction with HBO and is actually running in production at Ballarat School Systems in Australia. The way this application works is we utilize our OpenFlow infrastructure to intercept DNS lookup requests at the Ethernet access layer. Those requests are then compared in our controller against a locally cached IP reputation database that we synchronize with Tipping Point's Threat Management Center on an hourly basis. So we have hundreds of thousands of known malware sites, and we update them as they emerge in the environment. When a lookup is determined to be accessing a known command and control network, we immediately mitigate that port entirely and stop the threat at the first contact to the network. In addition, we are able to connect with the ArcSight security information and event monitoring system to throw alerts and create forensic logs that allow IT administrators to mitigate and remediate the environment, the individual that is offending. One of the most important things to consider here is that without this technology, you are forced to either apply dedicated and very expensive security technology in your wiring closets, which virtually no customers are willing to do, or you have to effectively mux all of your traffic back to your DMZ, entirely obviating the benefit that you have of the bandwidth in that location. This is of tremendous value, and Ballarat uses it, even though it's alpha product, in production because of the value it provides to their network. The next application I'd like to talk about is our UC&C SDN application for Link. We have integrated our controller with the Link server via APIs that allow us to understand when a Link session is being established. Moreover, to identify what kind of Link session. Is it a voice session, a collaboration session, or a video session? And then to apply the quality of service parameters to the flow dynamically in real time and tear them back down when the session has ended. This allows us to provision networks in a way that does not require them to be over-provisioned for the quality of service that is required for the most sensitive applications. And this framework is extensible not just to Link, it's extensible to any business application that requires specific quality of service handling. So in the past two examples, I talked about applications that we are applying primarily to the campus area. Neither of those applications are restricted to the campus area, it's just that we have customers that are looking to deploy it there now. Both of those applications can be extended to the data center, to the cloud, to the WAN. In addition, we are focused on more than just campus. We intend to deliver SDN capabilities to the WAN, both from an enterprise perspective and to the carriers in the form of network function virtualization, as well as to the data center and the cloud. And I list some areas where we believe there are real opportunities for innovation. What I can tell you is that we will build application in these areas, but we will not build every application that is relevant to this marketplace, which is why I'm happy to be speaking here today. We would like to invite this organization to think about how you might be able to bring your expertise and your innovation to bear on extending the application ecosystem and deriving real business value from the network. There are boundless opportunities, as the theme of TiEcon suggests, and we'd like to invite you to join us in exploring how we might uncover those. HP is committed to software-defined networking across the landscape. We are a founding member of the Open Network Foundation, ONF. We are a critical participant in the development and instantiation of the OpenFlow protocol, which allows the abstraction of the control plane from the infrastructure and the switches in a standards-based way. We are leading in ETSI to develop the network function virtualization specifications that are being required by carrier environments. And we are the #1 code contributor by employee at OpenStack. We intend to use our efforts in all of these locations to deliver comprehensive SDN solutions to our customers and to the marketplace generally. So when our customers ask us, they say, okay, this is great, we want to begin working with SDN. How do we start? This journey description is how we tell our customers to use our equipment to begin implementing SDN and working with the technology, but it can easily be mapped to any technology that is being offered by our competitors or by the open source community. The first thing we say to our customers is, well, prepare to be able to do something. We have switches that are OpenFlow enabled today. Start deploying them. That way, when you want to try something or an application emerges, you don't have to rip and replace. You can use the infrastructure that you've deployed. Next, once you have the equipment, we advise them to create a lab, download our beta controller, get involved in application development or use the applications that we are trialing with our Lighthouse customers. See how it can benefit you in your environment. And then deploy these applications maybe on a small production environment so that you can see whether or not there is real business value, just not obvious, interesting technology in your lab. Test and deploy newer technology. Work in the open source community. Work in the standards bodies. Make this fit the needs of the environment and create real business value both for the customers and for yourself. And then begin using the RESTful APIs on the northbound side in new and innovative ways. Create interesting applications that allow networks to operate more seamlessly and more efficiently than they ever have before. And finally, deploy SDN enterprise-wide. And as you can see, we believe this is a 2-year journey. And since it's a 2-year journey, that means there is real opportunity for entrepreneurs. And we would like to invite you now to join us on that journey, to develop and create the differentiation that will make SDN really meaningful to our audience. With that, I'd like to thank you very much.